Hello, everybody, and welcome to O3DCon 2021. Today's workshop, I'm going to be talking about coding gems. Now, I guess the first thing I should answer is, what is a gem? Well, a gem in O3D is a bundle of script assets, anything that would go into a project. This could be abstracted out into a gem, and this gem is then a piece of a project that can be used in many different projects. Just so we all know, my name is Colin Byrne. I'm the AR/VR lead and console domain lead on Lumberyard. Lumberyard has open sourced into Open3D, so many of the concepts may be familiar from Lumberyard, but many of them have been revamped for Open3D. Most likely when people hear gem, they should probably say to themselves plugin. That's more of a term that people are used to hearing with an engine and sort of a pluggable architecture. But it is actually much more than that. But more generically, a gem is an O3D object. All right, so what is an O3D object? Well, an O3D object is a discrete piece of O3D. Technically, any directory that has an O3D object JSON is an O3D object. Some examples would be things like a project. A project is an Open3D object. It has a project JSON. A gem, obviously, we just said is an O3D object and has a gem JSON. The engine itself is an O3D object and has an engine JSON. Templates, there are many others, but these are the main core ones that we'll be focusing on. All right, so what is in a gem JSON? What does it look like? Well, at its basic most level, all Open3D objects have a name. So basically, inside the JSON, there is a asset or this called gem JSON, and it has a gem name, right? So if it's an engine, it would have an engine name, template name, and so on. Basically, this is the sort of the crux of the registration system. Since all objects in O3D have a name, we can then refer to all of the objects in other objects or from the engine itself by name. All right, so same thing for an engine JSON. As you might expect, it has an engine name. This particular engine I'm going to call my engine. Hopefully you've noticed that yes, then each type is the same as the name of the JSON, so engine JSON, gem JSON, project JSON, and so on. Each JSON has an element that is that type underscore name, and then its name. All right, so where are these objects? We talked about them, but where are they actually? Well, they're actually any place on your file system. As I said, any folder with one of these files in it is technically that type of object. They can also be nested. So we would say that a O3D object can have children. And the astute among you might think, oh, I think I see a problem. If the O3D objects can live anywhere, how does O3D know where they are? Well, that's what the O3D manifest JSON is. It's a user level object, and this describes all top level objects. Top level object is something we say that has no children. Sometimes you'll hear it referred to as a root object. These objects are always found in the O3D manifest JSON. Okay, so once we register a top level object in O3D, we expect to find it in the O3D manifest JSON. Once in there, then we can query any of these objects that are registered by name. So these can live in different places on different people's machines. It does not matter as long as they're all referenced by name. All All right, so the O3D manifest, let's take a quick look at that. As we can see, it's in the users directory. On Windows, that would be C users, username, and it'd be .o3d, that's the folder, and the O3D manifest JSON lives inside there. Now the O3D manifest JSON has itself the O3D manifest name, just like any other object. And we currently set that to be the person's username because this is the user level object. The rest of it is basically just a bunch of lists of O3D objects. And as we can see here, there's 2 projects and an external subdirectory, and the very bottom, an entry for engines. All right, wait a minute. I don't see all the objects registered in here. I know that the engine ships with a whole bunch of gems. There's got to be 30, 40 of them in there. So where are they? As I said before, the O3D manifest JSON only lists the top level objects. And I also said that objects can have children. So for every top level object, say the engine will have an engine.json, and that JSON may have many multiple children objects. They could be gems, projects, templates, you name it. Everything that would be registered in the O3D manifest JSON would basically be registered in the objects JSON if it's a child object. So let's take a little closer look at the engine JSON. We see, again, the engine name, which will identify this object. We have external subdirectories. Not quite sure what those are yet. Projects, and then templates. So this engine is saying that it has a bunch of child objects, and it has relative paths to its children. The external subdirectories we'll get to in a bit. All right, and as I said, since these gems are in the engine, we consider them children of the engine, and the projects and the templates. Okay. Also notice that the top level objects that are in the O3D manifest JSON, they are always registered with full paths, and the child objects that we see in a file like this will almost always use a relative path. All right, so how do you register one of these objects? How does it get into these files? Can you edit just the files? Yes, you can. That will absolutely work. The JSONs are just the end result of the calls. However, we highly suggest that you use the scripts. The scripts that add these objects to these lists have a whole bunch of error checking and automation built in there to make things much easier for you. As I said, the lines are just the end result of these commands. All right, so these Python scripts, where are they? Well, they ship with the engine. They're in the engine's scripts folder. And we see that they have a bat, an sh, and a pi. The bat and sh are just the batch files for the different platforms for Windows and Unix-like systems that inevitably end up calling O3D pi, the Python file. So an example, if we're in the engine's root scripts folder, I could issue a command to register this engine with O3D register this engine. This literally means register this engine with the O3D manifest JSON. All right, since the engine itself provides these scripts, this engine obviously knows which engine we're talking about, this engine. Otherwise, if we were registering an object, say an engine that was not this engine, say it was another engine that we had made, like an install or something like that, we could explicitly register it with an O3D register and then an engine path, and then we give the path to that engine. All right, so registration of top-level objects versus the child objects, how's that work? Well, usually it takes this form, so O3D register and then your top-level object path. And if it's a child, you would have O3D register the child object and then the top-level object. So you're telling it that this object belongs to this other object. So for the engine, let's say we register the project path my game. right? This is a top-level object. Therefore, I expect to find CMyGame in the O3D manifest JSON. This one is the registering a gem. So O3D register, gem path, CMyGem. This is a top-level object. I expect to see this in the O3D manifest JSON. This one is a child. So I get an O3D register, gem path, of CMyEngine, gems, myGem, and the external subdirectory engine path of CMyEngine. Notice that the object lives in a subfolder of myEngine. All right, so the results of those calls will inevitably end up with a new project in my O3D manifest JSON of CMyProject, which was the first one we called, and CMyGem, which was the result of adding the gem. The result of the child registration I expect to find in the engine JSON, and there it is, gems, myGem. Notice that it is relative path. All right, next thing I should touch on is default directories. We've already seen one already. It's the .o3d folder. And on Windows, we see that it's in the users folder. This is the user level object. Under that, there are a number of subdirectories. First one we see is third party. This will be the default directory for where all of your third party downloads will go to if you do not specify a third party directory on a command line. Engines. So we'll notice that there are subdirectories in here for just about every type of O3D object. So if I download an object from a friend, I can stick it in there and register it. It's a convenient place for it to live. Obviously projects, gems, templates, and so on. Logs is another good one. Eventually, most of our logging will go to this folder, although right now it goes to the users folder. All right, so how do we create a project in O3D? We give it the command O3D create project and then the project path. And note that this is a full project path, CMyProject. This creates a new project in CMyProject. Now this one, O3D create project, project path, my project. Note that this is not a full path. So where should this one end up when it's created? That's right, in the default projects folder. And gem creation is just the same. You can create a gem with myGem. This creates a new gem in the CMyGem. The next one is a O3D create gem. And note this is not a full path, a relative path. And I expect to find that, of course, in my default folder when it's done. Hopefully, we all see a pattern here. That is true for all of the objects. All right, so first, this is a gem workshop. So specifically, when we have this gem, we will need to enable it or disable it for a particular project. So how do we do that? Well, we use the enable gem command. So O3D enable gem, the gem name, myGem, and the project name, myGame. Note that these are not full paths. So what will happen is that the scripts will look up these names and then find their paths for us. The result of this function, as always enabling and disabling gems, is altering the enable gems JSON. That's in your this particular one, this project. You'll see enabled gems, and then on the bottom you'll see myGem. Disable gem is just the same and opposite. So O3D disable gem, gem name, and then the project name. All right. So the first question I usually get asked is, if I create one of these objects, do I have to register it? The answer is yes and no. The full answer, if you use the scripts, is no, because the scripts do that automation for you and they'll automatically register it. By default, it will always register on creation unless you actually tell it not to. There are some cases for this, and most likely in testing and stuff like that. All right, so that brings us to the next thing. When I actually create, what am I actually creating? Where does it come from? And that's where templates come in. If we look at the engine.json again, we can see that this engine ships with a couple templates. And I highlighted them here. They're the default gem and the default project. So what are templates? Well, a template can abstract any directory. So anything that we want, we can point to and we can say, create a template out of this folder. This includes, obviously, Open3D objects. When I create a project or gem, I can tell it to use a specific template. If I don't tell it, it will use the default template for that type. All right, so using projects, a project and gem templates would look like this. So we have O3D create project, just as we saw before, with a project path as CMyProject. This will use the default template because I didn't specify one. This line, create project, project path, my project, and I'm going to give it a template name now of default project. These two statements are identical because if I don't specify one, it will use the default project. And even further, if I do create project with a project path of my project, I can give it a template path instead of a template name. And this is the path to that template. So these three are equivalent. And then finally, if I have a template that I have made somewhere else, that's an example of a project, I can just give it that template's name and it will find it when it's registered and use that template to make the project instead. So as we see here, so O3D create project, project path my project, and then I give it a template name of my project template. And gem creation using a template is just might be what you expect. It's exactly the same as create project, except we swap out project with gem. So O3D create gem, and then we give it a gem path. Again, if I give it a template name of default gem, these are equivalent if I don't give it a name. And of course, I can give it a full template path, just like a project. These are all equivalent. And then if I had my own gem template that I had made, I can instantiate it with giving it that template's name. All right, so that's great. How do I create a template? Well, as I said, any directory can be templated, not just O3D objects. So in this example, I'll create a template, and I'll say that my source path is CMyGameCharacters Jane. Jane is not an O3D object. She's just a folder of assets and scripts. And I will tell it to place that template in CMyGameTemplates new character. So I use a concrete character, Jane, to create an abstract template called new character. So now all Jane text in that folder, including file names, folder names, and contents of text files, all instances of Jane, which was the name of that folder, will now become $name. This is the abstraction. I also notice that upon template creation, I will now have a new template in my project, and it's template new character. All right, creation from a generic template. We already saw like a project in Gem, creation from templates. So how do you do a non-O3D object? A generic template is any template that is not an O3D object. So what is the difference between an O3D object template and a generic template? Nothing, absolutely nothing. They're exactly the same. The only difference is on the creation side. We have specializations for creation that take care of a bunch of the automation process for us. So on this line, I'm going to create create from a generic template. So instead of using create gem or create project, I'll use the other keyword, which is create from template. In this particular case, I'm going to set my destination path to be see my game characters John. And I'm going to use that character template that I just made called new character. So now I have a new character, and wherever Jane was present in the old character, we got swapped out for John. As I said, the specializations do things for us, such as setting an engine's name upon creation, or if it's a project, or if it's a gem, you can even set the project. All right, so what does this template look like? Well, templates are defined by any folder that has a template JSON. So a template is basically just a JSON that has a name, and then it has two main sections, which are basically copy files and create directories. So basically this is the manifest of all of the files and folders in that folder that the template was created from. If we see it has file, it has a name, it has an origin, which is going to become important to us later when we talk about restricted platforms, and whether this file is templated or not. So during the process of making the template, was the source text of Jane in that case ever found in this file? And if the file itself is optional or not, because sometimes files we may set them to be optional. And of course the directories are the same. They have the directory's name, and then again there's an origin, which will become important for us when we talk about restricted platforms. All right, so the anatomy of the default gem template. If we take a look, we can see exactly what's going to happen when we instantiate. If we open up the default gem template, we can look down, and we can see in this example, we'll go into the platform, the code source, and we can see that we have $name in a lot of these file names. So there's $name editor module. So a concrete instance of that gem, I just call it, when I create the gem, I call it concrete. And then you can notice here that that source folder now has files in it called concrete editor module and concrete editor system component, and so on. So the $name that you would see inside of the template, you will now see replaced with the concrete text. If we look inside of the contents of a gem JSON, we will see that all of the instances, again, where we see name, will be now filled in with concrete. So the names of the files, the names of the folders, and the contents of the files. All right, so if we take a look at the concrete gem CMake text, we see a number of things. The first thing that we usually see is that we set the gem's path to be the current lister. That CMake command tells us that it's this folder that this current file is in. The gem JSON is right alongside it inside that folder, so we know that. We can set that to the gem path that we just created /gem JSON. We can read that gem JSON with the next line of O3D read JSON key, and this is basically how we would extract the gem name out of the gem JSON file. The next line is a little bit we haven't talked about yet, which really is O3D restricted path. Objects in O3D can have public and private parts. So say we are developing for a console or some platform that is closed source, but we still want to support that platform with Open3D. We would give it a restricted object, which is another type of O3D object, and that is sort of like an overlay you can think of to the file system. The very next function there, ly-get list relative pal file name, that's a mouthful, is basically the function in O3D that will turn whatever path that you give it into a restricted one if that for that platform, so the PAL-dir, if it exists. If it's not a restricted platform, say it's Windows, it will also find that for you as well. Okay. All right, so that we can also see right below that, the first thing that it really does here is we use that platform directory, that PAL-dir, to include that platform's gem CMake. So this is CMake commands that are specific to that platform. The next thing we see is it adds an external target path of the third party. So if your gem includes any third-party libraries, you can put them inside there. And then the last thing it does is call the add subdirectory on the code folder. So let's look at that. The concrete code CMake list will be initiated by that last subdirectory call. And again, the first thing that we see is that since this is in a new folder, we will actually ask the O3D system to give us the PAL directory for this new folder. And then from that, we can add that specific platform's CMake file. All right, so from there, we see in the CMake list file, we declare certain targets now. These targets in a gems context is, we would say in concrete would be like a concrete static target. It's always going to be in the namespace of gem because that's because it is a gem. And right below that, we include all of the common files. So this would be concrete_file CMake. This is a list of files that will go into this target that are the common files. And then right below that, we see the PAL-dir invoked again to include the platform-specific files. Then we have another target that we add, and this is the one that is going to be driven by the PAL trait for the monolithic module. So if this is a library, if this is monolithic, this might be a library. If it is non-monolithic, it'll be a shared library. And we put those files inside of the concrete shared files, so we know the boilerplate for the shared library. And then, of course, the same pattern keeps repeating, and we have the platforms directory file right below that. All right, the next thing we see is that our number of aliases will be created to this target. So this is if this gem is being used by the client versus the server, we can alias these gems, and then the server and the client can include the correct files. And we can also change those targets to be something different if we wish. All right, now, next thing it says is if there's a trait for building the host tools, we can turn that off globally, which is what that flag is. So say we're in release mode or something like that, we probably will not be building any of the host tools in release. So here we're adding a target, and this is for the editor. So we see concrete.editor static. Again, this is also a gem, of course, and it has the concrete editor files. So these are the common editor files for this gem. And then we see that there's a build dependency on gem concrete static, which was the implementation that was above. And the last one is the gem module for the concrete editor. And we see that it has its own file list, and again has a dependency on the concrete editor static, just like the previous example. And again, we have a couple aliases that we create based on that. So if it's being used by the tools or being used by the builder. All right, the next thing that we always see in this is tests. We like to test our code quite a bit. Again, it follows the same pattern. There's a global trait for building tests which are supported that can be turned on and off. And then the second one we see here is the PAL trait for concrete tests supported. This is the one that's turned on and off by the platform. So Windows may have this platform set such that I can build these tests, but another platform may not support that test. And then we can turn it off here. And the pattern repeats, and we add this to Google Test. All right. So concrete gem assets. If I wanted to add any asset to this gem, I would add it to the assets folder inside of the gem. This assets folder is automatically picked up by the editor. We can add more in different folders, but we would have to manually specify that the editor to pick them up. So say I have a texture, and I just want to stick it inside this gem to make it available. I could put it inside of the gem concrete assets folder like this, texture.tiff. And I can group them. Obviously, it's a file structure, so I can put them into textures and then just texture.tiff, so I can group things up. Anything below the assets folder will be taken. Also things like FBXs and prefabs, icons for the editor, shaders, anything like that you can stick in there, menus. These will all be picked up by the editor, by the asset processor. All right, so how do I enable a gem once I have it? I have this gem, I just created it. How do I get that into my project? Well, we would issue the command o3d enable gem, and we would give it what the gem's name is. In this case, it's concrete, and we would give it the path for the project name. Note that it's not a full path. It'll find it and then add it to that. If I want to disable, it's exactly the same thing. I just change enable to disable gem. All right, that's all the command line, and that's great. All of these things are driven or can be driven by GUI, and that's what the project manager is. The project manager will show us our projects. If we look up in the upper right-hand corner here, we see that where we would press the button to create a new project. So when we issued the command o3d create project, this is what's actually calling that script from a GUI. Then you'll get this screen, and these are the familiar parameters that we would supply to create project. So we would give it the name, where we want it to be, what template we want to use. It says standard here. Standard maps to the default template. Then we would press configure gems, because since this is a project, we can configure our gems even before we create the project. And then we would hit create project. All right, so we already talked about enabling and disabling gems. We can also do this through the GUI as well. If we look to the bottom right of the actual projects that are listed here, we'll see an option to click. And we get the edit project settings pane. And then we see configure gems in the upper right-hand corner. If I click that, I will get the configure gem screen. This will list all of my gems and whether or not they're turned on or off. I only care about the concrete gem here, so I will type in the filter up here, concrete, and this will filter down to the concrete gem because that's the only thing called concrete in my engine. And then I click this button right here and I enabled it. That's all you have to do through the GUI. That's really it for this gem workshop. Thank you for watching. If you have any questions, please join us on Discord. You would go to o3d.org, and in the upper corner, you would press community, and right there in the center we have join the conversation, and the Discord link is right there. Thank you very much.